Hello guys, so now continuing to the previous videos on MCP. So far we have discussed about this how here this LLM models, right, and agentic agent code, right, communicates with the APIs and gets the real time weather data, right. Now, so in MCP world, right, these API call direct API calls from agents are removed. Now let's see what all are there. But before that, just I want to reiterate the issue that just imagine that this LLM application, right, needs to interact with a Slack, or it needs to interact with maybe some AWS services might agents have been used, and or any Gmail service, etc. So it gets very tedious to orchestrate and maintain all these connections. So this is how MCP was born. So if we go into the MCP world, instead of you creating and maintaining all these different APIs and URLs, so what it does is that whether this weather tool developer, right, whosoever is developing this, right, whether whosoever is, they have to expose one MCP server. You can see right in this slide, the developer need, who is the provider of this tool, they need to develop this MCP server, they need to expose this MCP server. So for this, another, say, hotel price, right, developer, he need to provide this MCP server B for this hotel related, right, all those services. So, and to come agent need to communicate with this MCP servers, so they need some protocol which is called MCP protocol, which need to be used. And as we discussed, right, in previous slides or previous video, that it will be using this JSON RPC as a standard for its communication. So this MCP server has a connection mechanism and has the information what fields this weather tool expects and what fields it returns, and what the developers of each tool can write their own MCP server. So let's say weather tool has MCP server a hotel price tool has an MCP server B. So in your code, you simply connect to this MCP server. That's it. Nothing else. You simply just connect to this server, and it will do the rest of the thing. Below, I have added some piece of code also. So in MCP world, right, you need this piece of code, right, to communicate with the MCP servers. And MCP servers, how, right, it can communicate with the tool. So this code is pretty standard and pretty simple to execute, and I'll demonstrate this in maybe in subsequent videos, that how you can, right, you can create your MCP servers and all. So see, it uses basically a mechanism called reflection. So in this reflection mechanism, this MCP clients, basically it connects to the MCP servers, and these clients, MCP clients, they generally ask, hey, what you do, what you can do for me, and the server responds with a list of all the available tools. Okay, MCP server responds with all the list of the available tools, and also their descriptions also it will respond with all its input output schemas, right. So see, this client, the client does not need to hard code anything. See, this is the beauty here. The client does not need to hard code anything. See, it's simply asking the server, irrespective of the tool, hey, what do you do, what can you do, what's your input, what's your output, and then client register these capabilities and make them available to the LLM for use in the user's interaction. So what does that mean? Let's say today this weather tool gives output A and B, and MCP client is simply asking MCP server A, what field or what is the schema of the output field you give. In this case, it will return, I am outputting say A and B. For example, this guy is outputting something A and B. Okay. And let's say developer comes and add another field X, and simply MCP client will ask MCP server, give me the list of the fields you return, and MCP server will return say B, say X and Y. Okay. And it's all dynamic fields, and then client can get all the fields and passes it to the LLM. There's no hard coding involved. So that's why this the maintenance and custom codes becomes very lesser, and it's the same standard code to connect to every MCP server, right? So previously with API based, right, you have to maintain a separate API integrations with each of these tools. These MCP servers are the standardized. You need to have some code to connect. This is the traditional client server architecture, so we call that MCP client. And now think of this, instead of these different tools having separate servers, which is fine. You can also have a single MCP server with all these different tools, because this is an open source. It's really up to you. You can take all these tools that your LLM uses, and then you can put it in your single MCP server, and then you can just call the single MCP server, and then using list tools from your client, and it can list all the tools as well as all those what inputs it takes, what outputs it's giving, right? So in our case, you can see it's here you see server.py, right? So in this server.py, right, it does all the things to get the weather information and all, right, for the server.py. So this is a Python file, server.py, which does all those things, which is basically provided by the MCP server, and that's how it works. So let's take another example. Say you want, so let's take another example. So let's take say all. So basically what it does, these reflections we have discussed so far. So it does what? It does the connection establishments. So MCP clients connect to an MCP server. Okay. So it does a connection establishments and capability discovery, right? Because it asks, hey, what all capabilities do you have? So it's a client request. So it does a capability discovery. And server reflections, like server responds with like list of all the available tools and tools descriptions and input output schemas, those things and blah blah, all those informations it will respond. And capability registration, the client, obviously client after, right, seeing that list of the available tools, etc., right, client registered these capabilities, make them available to the LLM for the user interaction. So basically all these things need to be done at this reflection side using MCP protocol. Now let me showcase. There are many clients which are already pre-built available. So as you can see here, this is a model context protocol.io site. Here you can see example clients, a list of the applications that supports MCP integrations. So Firewire, Agentic AI, and you can see clouded desktop app, right? It supports with resource, prompts, tools, and line as well. You can see cursor supports tools. So there are plenty of, see Mindpal. So all the details are available. You can see Firewire is an open source cross-platform AI assistant that support tools through MCP server. So built-in MCP server can be quickly enabled and disabled. So these are pre-built MCP servers are available, and these numbers are increasing day by day. So like just take case of Bolt AI. So it's a native and all in AI chat client with MCP supports. Cloud writes interactive agentic code tool from the Anthropic that helps you to code faster, and it supports MCP integration for prompts and tools, and also functions as an MCP server to integrate with other clients. There are plenty of it. So in next video we will be going to see a hands-on and a live demo as well, how to create MCP servers and how clients can call this MCP server and all. Yeah, thank you.